Hi, welcome back to ChemTube channel. I'm Jack Wong. Today we are going to look at MRSM trial paper 2 in section A. Let's start. Question number 1. Table shows the melting and boiling point of 4 substances P, Q, R, and S. Okay, you can see in the table 1 here. So based on the table, first state the meaning of melting point. So the melting point refer to the temperature at which the solid change or turns to liquid at certain pressure. Okay, so the keyword here need to mention the temperature, then solid turns to liquid at certain pressure. Okay. Number 2, what is the physical state of the substance R at room temperature? So remember, room temperature, we standardize it at 25 degrees Celsius. Okay, so what is the physical state at for substance R? So we look into the substance R here. So we put in the location. Okay, if you are not very sure, okay, we can draw a line like this. Okay, so this is, let's say, is a melting point, and then another one is a boiling point. Okay, so let's say before the melting, the physical state will be in the solid. After the melting, it becomes a liquid, and after the boiling, it becomes a gas. Okay, so we can put in the condition for the R. The melting is negative 77. Okay, boiling is negative 35. Okay, so for substance R at room temperature, so 25. So we can see where is the 25. So negative 77, negative 35. So meaning that 25 will be somewhere here. 25. So what is a physical state? So you be it in a gas form. Okay, yeah. So we can try with another substance. Let's say we try with Q. Okay, now we try with Q. Okay, let's say we try with Q. The melting is negative 6. Boiling is 700. Okay. Then at room temperature is 25, so we can see 25 is somewhere between the melting and the boiling point. So the physical state will be for Q will be liquid state. Okay. Then for S, 327, 1749. So we can see the 25 is somewhere in the solid state. So the physical state will be in the solid state. Okay? So that's how we solve the questions like this. If you have any question, you can write at the comment below. Okay, state the change of the kinetic energy of the force of attraction between the particles of Q when cooled from the room temperature to negative 10. Okay, so again, room temperature is 25 degrees Celsius. Okay, so we look into the Q here. Q just now will be in the liquid form. Okay, change to negative 10. So meaning that 25. Okay, we block here. So like that, somewhere 25. Change to negative 10. Negative 10 is somewhere here. Negative 10. Okay. So meaning that from liquid change to solid. Okay, liquid change to solid. So what happens to the kinetic energy? So number one, we can mention kinetic energy. What happens to it? It will decrease. Okay, decreases. Okay. So number two, the force of attraction. So force of attraction goes from liquid change to solid, so it becomes stronger. Okay, yeah. Okay, B. Diagram shows the reaction of the first three elements of alkali metals with water in the three beakers labeled with W, X, and Y. Okay, so normally if alkali metals in the lab, we always do for the potassium, sodium, and lithium. Yeah. Only these three are allowed in the lab. So sodium, potassium is the most reactive, followed by sodium. Then least reactive will be lithium. So roughly we can see if more bubbles and then it burns. So this one definitely is potassium. Then followed by this one more bubbles. So meaning that this one is sodium, and then this one is lithium. Okay, so based on diagram, which beaker shows the reaction of potassium with water? So it will be beaker X. Okay, so name the gas evolve when the metal react with water. So metal react with water, so it will be hydrogen. Okay, the question asks you to name, so you have to put in the name hydrogen. Okay, and write the chemical equation for the reaction in the beaker W or Y. W or Y here. You can use lithium, you can use sodium. Okay, so let's say we use the sodium. Okay, sodium metal react with water, so you produce the alkaline solution. Okay, sodium hydroxide with the hydrogen gas. Okay, so we have to balance the equation. So hydrogen here got 2, here got 1, 2, so 3. So it's not balanced. So let's say we try to times 2 here. So hydrogen becomes 4. So this one times 2. Yeah, hydrogen becomes 4. So oxygen becomes 2, correct. Okay, sodium here times 2. So this one also need 2 times 2. Okay, so you also can replace the sodium with lithium because the question mentioned W or Y. So what can you infer about the density of the group 1 metals compared to the water? So you can see the metal and it floats on the surface of the water. So meaning that the density of the alkali metals is less than the water. Okay, yeah. Compared to water. So density is less than, okay, density of group 1 is less than water. Density of group 1 metals less than water. Okay, yeah. So, okay. Question number 2. Diagram shows the apparatus set up for a chemical cell. So question number 1, state the ions present in a copper 2 sulfate solution. So in the copper 2 sulfate solution, so copper 2 sulfate, it contains the copper and sulfate ions. In the solution, it contains the hydrogen and hydroxide ions. Okay, so set the ions present in the copper 2 sulfate solution. So cations or positive ions would be copper and hydrogen ions. For the anions is a negative ion, so it will be sulfate ions and hydroxide ions. So 2 marks. So state the negative terminal. Okay, now we look at here. So we compare the zinc and the copper in the electrochemical series. So we know that zinc is located higher position in the electrochemical series. So zinc becomes a negative terminal or called anode. Okay. Then copper is located lower in the ECS, lower in ECS. So becomes a positive terminal, becomes the cathode. So state the negative terminal, so it would be zinc. Okay. So after 20 minutes, state the observation at zinc. Zinc is a negative terminal, is the anode, so zinc will undergo oxidation. So zinc becomes zinc 2 plus, lost 2 electrons. So meaning that what happens to the zinc? Zinc will become zinc ion. So it ionized. So what is the observation, or what can you see? Becomes zinc, becomes thinner. Okay, or you can say dissolve. Zinc dissolve. Okay, or you can say zinc becomes smaller because it has changed to zinc ions. So write the half equation occur at the zinc and the copper electrodes here. So just now I mentioned already, so zinc undergoes oxidation, zinc produces zinc ion, lost 2 electrons. Okay, now we look at the copper electrodes here. So what happens to the copper electrode here? Copper is an anode, is a cathode. So in the electrolyte, we will pick from the copper and the hydrogen. Okay, yeah. So copper and hydrogen, we will compare it in the electrochemical series. So we found that the copper is lower in the ECS. Okay, so it will be discharged at the cathode here, at the copper electrodes. Okay, so meaning that the half equation will be copper ions, okay, gain 2 electrons, it forms a copper metal. So meaning that if the question asks you the observation becomes brown solid is formed, okay, or copper electrodes become thicker, yeah, this will be the observation. Now state the observation for the copper 2 sulfate solution. Okay, so copper 2 sulfate solution is blue color, blue color, because it contains the copper 2 ions actually. So what happens to the blue copper 2 sulfate solution? So next you need to explain. So we can, if we see the what happens at the copper electrodes, copper 2 ions, you gain electrons to form the copper 2 copper metal. So meaning that the blue copper 2 okay becomes paler, okay, or becomes light blue. Okay, why? Because the concentration of copper 2 ions decreases because it has changed to copper metal. Okay. Now, as students want to increase the voltage of this cell. Okay. So the concept here, if you want to increase the voltage, meaning that we have to increase the distance between the two metals in the electrochemical series. So suggest a suitable metal to replace the zinc. So as long as you can pick one metal which is higher than zinc, then to compare with copper, then it will be higher voltage. Okay, so suggested here, we can choose magnesium. Okay, beside magnesium, we also can choose aluminum. Okay, so okay, question number 3. Diagram shows a series of chemical reaction. Okay, zinc react with hydrochloric acid. So we know that it forms a salt and water. So if metal with acid, the gas will be hydrogen gas. Then solution T will be the salt, so it becomes a zinc chloride. Okay, in step 2, okay, it reacts with lead-2 nitrate. So zinc with lead-2 nitrate, it becomes a zinc nitrate and solid V. So solid V will be lead-2 chloride. So this step 2 is the precipitation reaction. Okay, so name the solution T. So you have to give the name. So it becomes zinc chloride. Okay, so gas you produce is a colorless gas. Explain how you identify the presence of U. Okay, so the gas U actually is a hydrogen gas. Okay, so hydrogen gas, okay, we can bring a burning wooden splinter, okay, near the mouth. Okay, the gas U now. Okay, first we bring a burning wooden splinter near the mouth of the test tube. Okay, it should be mouth of test tubes containing the gas U. So what can you observe? Okay, a pop sound is heard. Okay, pop sound is heard. Okay, in step 1, 20 cubic centimeter of 1 mole per cubic decimeter hydrochloric acid reacted with excess zinc powder. So write the chemical equation. Okay, so meaning that hydrochloric acid HCl react with zinc powder. So zinc is a metal. So it forms a salt, zinc chloride, and hydrogen gas. So we have to balance the chemical equation here. So hydrogen 2, here 1 only, so this one times 2. Okay, so we can double check chloride, so it's 2, and then it's balanced. So 2 hydrogen hydrochloric acid react with zinc, produce 1 mole of zinc and hydrogen gas. So calculate the maximum volume of gas U can be produced at room condition. Okay, so we know that first we need to calculate the mole of the mole for the acid first. Okay, number of mole for hydrochloric acid. So we use the MV over 1000. Okay, so we can replace in the information. The concentration for the acid given is 1. Volume it used is 20 over 1000. So you get, use your calculator, 0.02 mole. Okay, step number 2, we need to compare the number of mole for the acid and the volume of gas. Yeah, so the mole ratio is 2 mole of hydrochloric acid to 1 mole of hydrogen gas. So we can do the comparison for the mole. 2 mole of hydrochloric acid produce 1 mole of hydrogen gas. So if from calculation here, 0.02 mole of hydrochloric acid, so it produce 2 to 1 means half, 0.01 mole of hydrogen gas. So next we can calculate the volume of hydrogen. So it's mole times the molar volume. Molar volume at room condition is 24. So mole is 0.01 times molar volume is 24. So you get 0.24 cubic decimeter. So this is how we calculate the volume of gas. 3 marks. So explain how you can obtain the pure solid V from the reaction mixture. So solid V is the precipitation. So how we can get the pure solid? So first, actually we can elaborate more. Okay, first we can filter. Okay, filter the mixture. To get the solid. Okay, next we can rinse with rinse with distilled water. Okay, then number 3, we can dry the solid between 2 filter papers. Question number 4. Diagram 4.1 shows the formation of rusting on the surface of iron gate. Okay, so now A, state the condition for the rusting of iron. So rusting, it must have the presence of oxygen and water. Okay, these are the 2 conditions that the rusting of iron can occur. B, rusting of iron is a redox reaction. So name the substance that is oxidized. So for oxidation, they will oxidize with iron. Okay, you have to give the name, cannot give the formula. Write the half equation. So iron undergoes oxidation. So oxidation number increase lost 2 electrons. So iron gate rust faster in the coastal areas. Okay, yeah. Explain this phenomenon. Okay, why at the coastal area the iron gate it can rust faster? Okay, so because at the coastal area it contains the seawater. So in the seawater it contains the salt. Okay, and then salt. So normally you can form the salt vapor easily. Okay, so meaning that the presence of salt vapor near the coastal area, okay, will be you will be forming the salt vapor in the air. Okay, then it will increase the concentration. This will increase the concentration of electrolytes, okay, in the air. Okay, so this will increase the rusting process, okay, near the coastal area. So suggest one way to prevent the rusting of the iron gate. Okay, so there are several ways. You can choose any one. Okay, let's say we can pan. We can pan the gate. Okay, we can put on the grease. Okay, or we can galvanizing. Okay, galvanize the iron gate. Okay, so the diagram shows the apparatus to construct the reactivity series, of metal. So metal oxide mixed with the carbon, put into the crucible, and then we heat it strongly. Okay, so the concept here is, once we heat the mixture, if it burns or it glows, meaning that the carbon, it can displace the metal oxide. Okay, it can displace, meaning that the carbon is more reactive than the metal oxide. Okay, if no reaction, meaning that the metal is more reactive. Okay, so carbon cannot displace the metal from its oxide. Okay, so you have to know the concept here. Now we look into the observation here. Okay, carbon react with the aluminum oxide. Okay, so no change. No change means that the carbon not able to displace the aluminum from its oxide. So meaning that carbon is less reactive compared to carbon. So meaning that aluminum is higher position in the reactivity series. Carbon is lower in the reactivity series. Okay. Now, carbon with oxide of X. Okay, so brown solid is formed, meaning that it reacts. So meaning that carbon can displace the X. Okay, so meaning that X is less reactive. So X is lower position. Okay, in the reactivity series. So suggest the metal X. So metal X, you can see after the reaction it forms a brown solid. So brown solid in the SPM level, only one, that is the copper. Copper. So suggest the metal X, so it's copper. Okay. So based on the set 1 and 2, explain the difference in the observation. So there are two. Okay, in set 1, there is no reaction, right? In set 1, okay, no reaction occur. Okay. While in set 2, the reaction occur. Okay, or you can say the couple is formed. Okay, so why this happen? Because carbon is less reactive, okay, than aluminium. Okay, okay, but more reactive than X, or you can say it's copper. Okay, so you can say copper can displace the X from its oxide, cannot displace the aluminium from its oxide. Okay, same point as this, point number 2. Okay, so put 2 marks. So arrange the X, carbon, and aluminium in the ascending order. So just now we arranged already. So the lowest will be X. Okay, followed by carbon. And finally is aluminium. Okay, question number 5. 2 sets of experiments were carried out to study the rate of reaction between the magnesium powder and the nitric acid at room temperature. So diagram shows, table shows the result. So we can see volume 50, concentration 0.8 is on the same. Okay, but in the set 2 we have extra chemicals, copper 2 sulfate. So if in this case, okay, so actually it's a clue already. So if extra chemicals, it should be the catalyst. So the magnesium powder are the same. Okay, then the time taken for the magnesium powder to completely dissolve will be 30 seconds. Set 2 will be 12 seconds. So set 2 has a higher rate of reaction. So based on the table 5, state the meaning of rate of reaction. Okay, so we can mention actually in this one, okay, the time taken for the powder, magnesium powder to completely dissolve per unit time. Okay, or increase in the volume of hydrogen gas. You can see the hydrogen gas is released per unit time. So there are 2 ways for us to determine or state the meaning of the rate of reaction. So number 1, we decrease of mass of magnesium powder per unit time. Okay, or another one is increase in volume of hydrogen gas per unit time. Okay, so both can be accepted. Okay, next, calculate the average rate of reaction in the set 2. Okay, in the set 2. So just now we know that for average rate of reaction, we can use the decrease in the mass of the magnesium powder, so per unit volume. So the mass of the magnesium powder used is 0.4 gram. So the average rate of reaction will be average the mass, okay, so 0.4 gram over the time. Time just now for set 1 is 30 seconds. So you get 0.0133 gram per seconds. Unit must be stated correctly. For set 2, also the same. 0.4 gram over the time is 12 seconds. So you get 0.0333 gram per seconds. Okay, these are the two rate of reaction. So diagram 5.1 shows the energy profile diagrams for the set 1. So sketch the energy profile diagram for set 2 in the diagram. So set 1, let's say this is a set 1. Okay, so set 2, it has a catalyst. So as we know, if catalyst, so it will be lower activation energy. Okay. Okay. So this is for set 2. Okay. So if we want to make it more accurate, we can label the activation energy. Okay. So this is the activation energy for original. We put it E A without catalyst. Okay, then from here this is the E A prime. Okay, so this is for set 2. Okay, so activation energy with catalyst. Okay, we can see the catalyst will lower the activation energy, okay, of the reaction. Okay, so compare the rate of reaction in the set 1 and set 2. So explain why there is a difference, okay, based on the collision theory. Okay, so 4 marks. Okay, so there are 4 points. Okay, let's say point number 1, we can mention the rate of reaction. I use a short form. The rate of reaction in set 2 is higher than set 1. Okay, so we mention copper 2 sulfate solution is a catalyst, provides an alternative pathway okay, with lower activation energy. Okay, point number 3. So more collisions between the particles here, okay, between the hydrogen ions from the acid and the magnesium magnesium is a powder, so magnesium atom okay, can overcome lower activation energy. Okay, so finally more effective collisions okay, occur between the particles. Okay, so higher rate of reaction. So here particles, we can use particles here because in here point number 3 we mentioned already the particles that collide. Okay, so there are 4 marks here. We have to mention about the collisions that overcome the lower activation energy, the more effective collisions occur. Okay. Okay, the diagram shows 2 different conditions of storing food. So condition A in the freezer, okay, in the refrigerator, and then condition B, and put it on the table in a room condition. So in which condition will the food last longer? Explain. Okay, so we mentioned condition A can last longer. Okay, so why? Because at lower temperature, okay, the bacteria actually, okay, is actually less active. Less active. Less active compared to the room condition. So, and less toxic is produced compared to condition B. Okay, yeah. If less toxic is produced, then the food can be last longer. Oh, okay. So in condition B, at a higher temperature, the bacteria is more active and more toxic. Okay, question number 6. Diagram shows the formation of compound X from glucose and its conversion to several other carbon compounds. So you can see glucose to compound X, so undergoes process X, process 1. Okay, actually this is fermentation, and then compound X actually is alcohol, so becomes C2H5OH is alcohol, is ethanol. So ethanol undergoes process 2 porcelain chips, so it changed to C2H4 is the dehydration actually. Okay, then process 3 produce carbon dioxide and water, so this is a combustion. Then compound 4 is carboxyl group, so it's carboxylic acid, so it's oxidation. Okay, so if you can list out all the information, so it'll be easier for us to answer the question. Okay, name the enzyme produced in the yeast. So enzyme will be zymase. Okay, so draw the structural formula of the compound X. So compound X is ethanol, right? So ethanol, there are 2 carbons, so you can put in here hydroxyl group, then hydrogen. Okay, so this is the structural formula. So compound Y is formed when the vapor of compound X is passed over the heated porcelain chips in the process 2. So draw a level diagram. So in the dehydration, so dehydration process, okay, normally we'll try and draw a line first. Okay, so first we have to heat in the combustion tube, right? So we draw a combustion tube, use a ruler. first. So in the porcelain chips, right? So we have to put in the porcelain chips. Okay, we have to put in the glass wool first. Okay, and then we need to put we need to put a glass porcelain chips here. Okay, then the glass wool soaked with ethanol. We have to label all the here. Okay, so first we have to label here, so it'll be glass wool soaked in the ethanol. Okay, this is the porcelain chips. Okay, so both of these we need to heat it strongly. Okay, then here once you heat the ethanol, right? Okay, so ethanol pass through the hot porcelain chips, then you absorb the water vapor, then it forms a ethene gas actually, C2H4. Okay, so ethene gas is produced, C2H4. Okay, so how do we collect the gas here? So normally, okay, we will deliver it. Okay, deliver it yeah. So in the exam, if we draw like this, it'll be wrong. So the stopper must be a little bit come out. Okay, yeah. Then it flow it into the basin filled with water. Then the tube can put like this. Okay, put it lower a bit. Okay, so this is the gas. So we will collect. This is inside here still water. So we collect the gas. Collect the ethene gas here. So because ethene gas will be, so here will be ethene gas. This is water. Okay, so this is how we collect the ethene gas. So later on you can test with bromine water or acidified potassium magnate 7. Okay, so compound Y. Compound Y, so meaning that the ethene is the ethene gas. Y, yeah. So ethene gas, how do we test it? Okay, we can flow the gas into a brown bromine gas. Okay, yeah. Sorry, not gas, bromine water. Okay, so it turns the brown bromine, it turns to colorless to show the gas. Okay, the gas. Okay, the compound Y, the ethene is present. Okay, write the half equation, chemical equation. So it's a combustion, right? So combustion, C2H5O. COOH react with oxygen, so produce carbon dioxide and water. Okay, so we balance the equation. Start with carbon, so 2 times 2 first. Hydrogen, 5 plus 1, 6. So 2 times 3. So finally we check the oxygen. 2 times 2, 4. 4 plus 3, 7. So 7 here got 1. So here must be 6, so times 3. Okay. Okay, compound Z liberates carbon dioxide gas when calcium carbonate is added to it. Okay, state the functional group for the compound Z. So compound Z is a carboxylic acid, right? So it's a carboxyl group. Okay, carboxyl group. Okay, you can write COOH. Okay, so name a reagent that is suitable used in the process 4. So process 4 is oxidation, right? So oxidation, we can use the most popular oxidizing agent. Okay, so you can use acidified potassium manganate 7 solution, or another one would be acidified potassium dichromate 6 solution. Okay. Compound Z react with compound X to produce a substance with a pleasant smell. So pleasant smell with ester. Okay, write the molecular formula for the substance produced. Okay, so compound Z. Okay, let's look back. Compound Z. Okay, compound Z is the ethanoic acid. Compound X will be ethanol. Okay, so ethanol, ethanoic acid. So the molecular formula, so it will be C2H5COO. Okay, then from the alcohol C2H5. Okay, so this one is called, although not asked in this question. Okay, actually it's ethyl ethanoate. Okay. So that's all for the MRSM paper 2 in section A. If you have any question, you can leave the comments below, and I will try to explain more on your questions.